Today we are going to discuss about an important parameter is one of the categories Otto cycle. So it is an application of it is the application under the category of Aero Thermodynamics. This Otto cycle is the application of internal combustion engines that is called as an IC engines. So internal combustion engine is a category about two-stroke engine and four-stroke engines. These two-stroke and four-stroke engines are primarily based from the usage of fuel supply to that engine. It is an fuel injection area, and it is an as a petrol type. One of the type is petrol type and one of the type is diesel engine type. So these categories and these types will be based parameter of using of efficiency. And this Otto cycle is basically classified, or it is basically derived from the four type of cycles. So it having a two adiabatic cycle and another one is two constant volume cycle. So this is the cycle process of Otto cycle, two adiabatic and two constant volume cycle. In this two adiabatic and two constant volume cycle, it is category of, in this two adiabatic, one of the criteria is heat supply area and another one of the category is heat rejection area. So is the heat supply and heat rejection area, followed by that the two constant volume cycle, it is the process with respect to the temperature, pressure and volume relation. So this is the cyclic process of constant volume cycle, and additionally it will be having the PV diagram of pressure volume diagram with respect to the, previously we said that about two adiabatic and two constant volume is the process 1 and 2 is a adiabatic process, and process 2 to 3 is constant volume process, and process 3 to 4 is adiabatic process, and process 4 to 1 it will be a constant volume process. So this is the pressure, volume and diagram with respect to the constant volume cycle. From this adiabatic cycle and constant volume cycle, we equate the equation for heat rejection and heat supply is with respect to or relevant to the constant volume process is mCv T2 minus T1, and heat rejection area is mCv T3 minus T4 minus T3. So here it is the heat supply and the heat rejection part is mCv T2 minus T1 and mCv T4 minus T3 of heat supply and heat rejection part. So finally we have to apply this heat supply and heat rejection into the work done equation. Basically we know that work done is equal to heat supply minus heat rejection. So we have to substitute this heat supply value and heat rejection value in the work done equation. We get it the work transfer or work done for Otto cycle. And finally we need to know about every cycles that will be having some type of efficiencies. So here is the efficiency is equal to work done by heat supply. So the work done, it is the ratio of heat supply minus heat rejection, and efficiency we have to supply in heat supply also. So this is the internal combustion engine part, and it will be focusing or it will be applicable to the constant volume cycle. It's one of the respect ratio and one of the product of two-stroke and four-stroke engine. With respect to previously we said that about it is fully about the fuel part of petrol, diesel and injection, it will be the spark plug parts also. So this is the working and pressure volume cycle relations of
Otto cycle is the another name of constant volume cycle. Thank you.